All right. So yesterday, I realized there was still a little bit of confusion when it came down to identifying the base. And if you couldn't pick the right face of the polyhedron as the base, it kind of messes up the rest of the formula and your math. So I actually, when I thought about it, because to me it's just so intuitive picking which one is the base, I never really had to give much thought to defining what makes something the base or not, and I actually taught you wrong. So I came up and found a few counterexamples to what I told you yesterday. So let's go through this. It'll be a really good, a good little exercise for us, and it's very humbling for me because I am human and I do make mistakes. And this was an easy one, and I've been teaching this wrong for a while now. So I'm actually pretty excited because even though I'm so old, you young whippersnappers don't know, but I'm so old, and yet I still learn new math, and that's exciting because there's still stuff out there for me to learn. So I'm genuinely excited about that. I'm gonna watch some math YouTube videos later after this. But anyway, so how do we identify the base? Well, let me tell you what I taught you yesterday, and then I'll show you why it doesn't work for hexagonal prisms or octagonal prisms. Yeah. Anyway, I wonder if you noticed, but pretend like you didn't. I'll point it out later because that's how I roll. Anyway, so I told you that in order for it to be a base, it has to have another base that's on a parallel plane and congruent to it. So for instance, if we looked at the hexagonal prism here, now this is a hexagonal prism, so the correct base should be the hexagon, the one that's in the front and the one that's in the back, right? So you do have two bases. They're both congruent and they are on parallel planes. So that is true, but that's a description of the bases. That's not necessarily a way to define the bases. So it's a subset of bases, but it doesn't actually, it's not a a definition, so it's not biconditional. It doesn't go both directions. So that's where I kind of got in trouble, because there's a counterexample. There is elements that exist outside that set that are actually the bases in this case, or that are not the bases. Okay, so look at the top here. This rectangle. We also, if we move this down, there's a congruent rectangle that's on a parallel plane. You see that? But the rectangle is not our base. So, wow, what I taught you yesterday just flat out does not work. So same thing here on the octagonal prism. It just rolls off the tongue, right? That's funny because I think it's funny. Okay, fine. I'll fix it. Whatever. It sounds exactly the same. I mean, yeah, octagonal prism. Okay. So on this one here, we have our face that's on the right side, but we also, on a parallel plane, have another congruent face, but that's not the base. This is an octagonal prism, not an octagonal, but an octagonal prism. So I guess I'll put it back here. So how do we delineate between those two? So how do we if it broke down, it doesn't work, right? The octagonal prism here, the octagon in the front and in the back, they're on parallel planes, right? Just like I said they were. Okay, they are congruent. The same thing with the hexagonal prism. Yeah, that works, but it's not unique. That doesn't actually work for this one. Both of them are true, and in fact, all of them are true. In any one of the faces that is on one of these two shapes here could be the base by that definition, and that does not work. So how do we identify the base? So the new way, the proper way, I believe, take two, is that we know the lateral surfaces, the lateral faces of a polyhedron will always be rectangles. So the two bases are going to be connected by straight lines that will form rectangles, going all the way around. So all you have to do is look at the faces and look for a shape that's not a rectangle. So on the hexagonal prism, we've got 6 rectangles and 2 hexagons. So what face is not a rectangle? The hexagon. And that tells us that the hexagon has to be the base. It's that simple. And there's one exception, I'll say, of course. But then on our octagonal prism, we see 8 hexagons, which are forming the lateral surfaces that go around the base. the two bases, right? Which are the octagon. So do you see a face that's not a rectangle? Yes, the octagons. So the octagons have to be the base. It's that simple. So look at these prisms here. We're going to use our new rule now. So we know this is a triangular prism. Do you see any faces that are not rectangles? So we got 3 rectangles forming the lateral area going around the triangles. Yes, so this would be a triangular prism. All right, and we do have a congruent base up there, right? And it's on the parallel plane, but that's a description, not a definition. All right, same thing here. Do you see any that are not rectangles? Oh no. See, there's a special case. This is a rectangular prism because the bases themselves are rectangles. So if all of them are rectangles, then that means it has to be a rectangular prism, and then it doesn't matter which one you pick to be the base. We usually default to the bottom one, the one on the bottom face, but that's okay. You can pick any one of them, and the formulas will still work. It's totally fine. So we do have one that's on the parallel plane up here, so we could pick the bottom rectangle, right? That would be fine. And there's lateral surfaces, rectangles going around it, which is what we need. We could pick the left or the right face, or we could also pick the front or the back face, which I demonstrate over here on this special rectangular prism, which if they're all squares, we call it a cube, okay? So, and again, could be the top, could be the bottom, right? So all of these are rectangles, squares are rectangles, right? And so that means it's a rectangular prism or a special one called a cube. So look at this one here, this prism. You see our lateral surfaces, all of our rectangles going around. Well, what shape are they going around? The pentagons, of course, right? So do you see any shapes that are not rectangles? Yes, and it's a pentagon. So that will be a pentagonal prism. So that's the only shape that's not a rectangle. So that has to be the base because the lateral surfaces will all be rectangles. All right, all these are rectangles, the lateral surfaces. Do you see any that are not? Yes, the hexagon. That just so happens to be on the bottom, right? And so this is a hexagonal prism. So they're not usually that difficult when the bases are on the bottom, but sometimes the prisms are sideways. They're on their side. So I made all these prisms here just to demonstrate the process still works. So what is the? In fact, all of these they all have rectangles on the base, right? And half of them have rectangles that are on a parallel plane right above it, just like this one, right? That's congruent to the one on the bottom. Same thing with this one, and the same thing with the hexagonal one right here, right? So that previous description of the bases is not true. I'm just hammering that home. Okay, so what kind of a prism is the one on the far left here? Well, that would be a triangular prism. And how do we know that? Do you see any shapes that are not rectangles? Because all the lateral faces have to be rectangles. So the triangles cannot be the lateral surfaces, so they have to be the bases. And there is one behind it. So there's 2 bases and it's a prism. Do you see anything that's not a rectangle here? No, they're all rectangles. So this is a rectangular prism. So again, we can pick any one of those to be our base and our formulas will still work, but we're going to default to the one on the bottom. Do you see any shapes here that are not rectangles? Yes, obviously the one in the front is a pentagon, okay? And we have another pentagon in the back. So those are our 2 bases, and the lateral surfaces are the rectangles that go around. Anything that's not a rectangle, yes, it's a hexagon, right? Hexagonal prism. And this one has 7 sides, the same thing, right? A heptagonal or septagonal prism, depending on if you want to do the Greek or the Latin, and then the octagonal prism. Yeah, see, now that I've said it like 4 times, octagonal prism just rolls right off the tongue. I don't even stutter anymore. You ready for the really cool visual effect? Look, it was hiding there the whole time. Let's pick red. Whoa. This is so cool. Watch. That is so dope. Oh my gosh. That is so fun. Okay, yeah. I am having a lot of fun doing all this graphic design work with my my digital writing pad. It is just so much fun. Anyway, I can't even draw straight lines, but digitally I can do really cool stuff. When I found out that I could do that, like lock them all together, and because that's how I formed the whole things in the first place, like they're just so cool. Okay. So whenever we're talking about pyramids, so the lateral surfaces of pyramids are always triangles. So if you see a bunch of triangles, do you see any surface that's not a triangle? Yes. So in this case, it's a square or rectangle. So this would be a rectangular pyramid. This one, the only side that's that's not a triangle is going to be the hexagon. So that's a hexagonal prism. This has 7 sides, so hepta or septagonal, and then decagonal, right? So no one struggles with finding the base of a pyramid. I shouldn't say no one, but typically that's very intuitive. The problems start to come in when we deal with prisms that are on their sides, they're oriented in different ways. Typically, we like to orient them with the bases on the top and the bottom faces, but they don't have to be. They can be sideways just like this. So I'm going to stop talking. That was 10 minutes of me admitting that I was wrong and cracking, terrible jokes. But yeah. Make sure you watch the other video, which will actually be the lesson. So this one, that was cool. It was cool. All right. So thanks for bearing with me. Even though I do make mistakes, I caught it, and we're going to move on.